I'm going to present LeanXcale. LeanXcale is a new database that is a result of many years of research on transactional and data management. Currently, we are working with several big companies in different verticals like banking, telcos, travel tech, and so on. So I will go through this series of pains that we solve, how we solve them. The first one is the lack of scalable operational databases. As you know, operational databases, they don't scale, and they are the main IT bottleneck. For this reason, what we have developed is an Ultra-Scalable transactional manager that has solved the key bottleneck on operational databases. That is how to scale out the asset properties. Our database is able to scale from 1 to even thousands of nodes. It scales out linearly, and it provides full SQL and full asset properties. In this way, enterprise architects don't have to waste any more time in twisting the business application in order not to break the operational database. They know that LeanXcale will handle any load that they might run on it, and then they can devote all their time just exclusively to solve their business application logic. The scalability of the database is such that can even substitute the mainframe. It's the only technology that can do that today. So the second pain that we solve, as you know, today enterprises, they have two different kinds of databases. They have the operational databases, and they have the data warehouses. Because of this separation between the two database systems, they have to copy the data from one into the other in a process known as ETL, extract, transform, load. And as you know, this is a continuous headache at companies and waste of money and effort. It requires 24 times 17 maintaining the ETL. Also, it has to be developed, it has to be planned and scheduled so it doesn't disturb the operational database. And additionally, the analytics that you get out of this architecture, they are over stale data, because typically it's data that has been copied the day before or the week before, so you are getting stale analytics. So the way we have solved this is by we have combined like 8 different innovations that has allowed us to combine in a single database system the two capabilities, the two features. So we are providing a database that is an operational, ultra-scalable database, but that on the other hand, it has data warehouse capabilities. Basically, what we have is a data warehouse engine that is working directly over the operational data. And therefore, you get real-time analytical queries. You get analytical queries that are working on the real-time data. With this, you don't need to have ETLs anymore. On the other hand, now you are getting analytics over the fresh real-time data. So if you have perishable insights, they will not expire. You will be able to actionate them immediately as they are discovered. Another key feature that LeanXcale has is that is fully elastic. Let me detail what I mean by this. So our storage engine is a distributed storage engine that is able to migrate fragments of data from one server into another server without stopping anything, not even disrupting the quality of service of the transaction, accessing this piece of data that is being moved. With this, we are able to provide two key features. One is to be able to dynamically balance the load in a continuous manner. So in this way, you are guaranteed that you have a cluster and the full cluster fully utilized, taking into account that regular solutions, that what will happen is that if you have a cluster of 10 machines, some of them will be overloaded, some of the other machines will be underloaded, and then you will not be able to fully utilize the whole cluster. In the case of LeanXcale, because of this capability of being able to migrate data in a non-intrusive manner, we can perform dynamic load balancing in a continuous manner, guaranteeing that the whole cluster is fully utilized. Additionally, we can deploy new servers dynamically. The log will be distributed along all of them, or we can decommission servers that are not needed anymore. And again, this can be done in a totally non-intrusive manner. Another important characteristic that we have is that our architecture is based on a proprietary storage engine that is a distributed scale-out storage engine. In fact, it's a relational key-value data store that we have developed. And then on top of this, we have a distributed query engine that is able to distribute both the OLTP and the log workload. Now, because of this peculiar architecture that we have, now it turns out that you can access your data through SQL and a regular JDBC driver, but because the storage layer is a key value, a relational key value data store, you can access the same data without using SQL directly through the key value interface that provides you not only puts and gets, but scans and scans with predicates. This means that then for simple operations like data ingestion, if you have an application with a large data ingestion, let's say stock trading, or it can be an IoT application, the ingestion of data that will be consuming most of your resources on the data management data manager, it can go through the key value interface and therefore highly reducing the cost of ingesting all this data. Also, if you have simple queries that are range queries with predicates, they can also go through the key value interface, saving a lot of the overhead of SQL processing. So basically, you can use either of the two interfaces, whatever is more convenient for you. So a little bit more about our storage engine that is called Kiwi. Kiwi has several innovations there. One is that is ultra efficient. It's based on a new invented data structure that allows us to be highly efficient for insertions, like key value data stores, but we are also highly efficient for range queries, as SQL storage engines are. The other thing is that we are vectorial, so we are using today commodity servers. They have vector processing like the old supercomputers, but now it's available in AMD and Intel regular servers. So we are taking advantage of this single stage of multiple data vectorial register and vectorial register to get an acceleration both for the searches and for the SQL query processing. The architecture is radically new. You cannot find anything similar to us in the market, and it's highly efficient for multi-core and many-core architectures and NUM architectures. We are able not to consume any CPU cycle for thread context switches, thread synchronization, and remote NUM accesses. Also, we are hybrid row and columnar storage. And with this, we can get a columnar acceleration for analytical queries when you perform over tables with a larger number of columns. So finally, as a summary, LeanXcale is an ultra-scalable operational database. It's a full SQL, full ACID database. With this, you get what you can get with Oracle or any regular operational database, but it's a shared nothing database that can scale out linearly as much as you need. From 1 to thousands of servers, it can reach even billion a day transactions per second. So basically, you don't have to worry anymore about the scale. You know that the database will handle it for you. It has the two capabilities, operational and analytical, so you can run analytical queries over your operational data. Then, because our storage engine is a key value data store, relational key value data store, you can choose what the interface is the more convenient for the different parts of your application. It can be either SQL or the relational key value. And the solution is fully elastic, so you can adjust the cluster size dynamically to whatever are your needs. So this is contact information. If you have any questions, we have a stand at the Innovation Pavilion. I will be there. I will be happy to answer any questions that you might have. Thank you.